Accessing library computer data.
Hello and welcome to another video vlog episode of Building Enterprise D. Now, if this is the first time you've seen one of my episodes or you just subscribed, it's more than likely because of this. Yes, that's right, I've done it. I've actually developed and made the Enterprise D phaser array effect seen in Star Trek Next Generation, Deep Space Nine, Voyager and the movies as well. And it's bloody hard to do because I needed to get my very own commander data. Well, he's called Jan and he's been superb. He's a guy I've commissioned to actually help me out sort out the coding for the Arduino Uno unit to be able to get that effect. And he's been superb. He's a wizard. He's like Neo from the Matrix. I bet he just sees ones and zeros, and he can probably agree to that as well. And so I've popped it all together, and as you can see, it works. Now, a little bit of disappointment for some of you out there who are watching this video just because you want to know how to do that. Because there's so much detail involved and there's a few things I still need to sort out in regards to power supply. Now, the entire Enterprise D lighting system runs on 12 volts and that specific effect runs on 5 volts, and so I need to somehow work out how to actually step down that voltage by using capacitors, resistors and a little bit of magic and God knows what else to make it all work and be integrated. However, Spock's honour, I will share everything with you. I will perhaps dedicate an entire episode, no, correction, I will do an entire episode on that build because I wanted to make it simple and accessible for anyone to be able to build that because it's just so cool. So anyway, if you just hold on tight, if you subscribe, that's great. Either way, I will post that video up in the future. It's going to take me some time to actually work out how to step down that voltage, but also to be able to actually draw out all those plans so everyone can understand them, as well as work out a way to supply you with the Arduino code as well. Now, as titled, this episode is called Interior. Well, it's going to be probably 1 or 2 or 3 episodes of the interior because, as you probably know, there's so much work and effort that goes into the interior and preparation of lighting a model. So rather than me just bang on right now, because if you're anything like me, you probably would have skipped the entire introduction of this YouTube video because they're boring and you just want to get down to it. So let's just start, shall we? A pair of Buzzard ramscoops. Now, there's a lot that goes on with this little part of the model because this is going to go on the warp drive, and if you've seen Star Trek Next Generation over and over again like I have, you'll notice there's loads and loads of subtle details on here. Unlike other Enterprise models, there's no movement in here or no blinking or pulsating. What there is, there's a plasma effect inside the Buzzard ramscoop, and there's a couple of ways you can actually get that effect. Now, first thing I done was key this off with some wet and dry to make it all frosted so the light diffuses, and then I filled it with cling film or cellophane. Wherever you come from, it may have a different name to it, but essentially it's that same wrapping you use for sandwiches, and I put that in just a little bit, just enough, and scrunched it up, and it gives you a lovely effect of plasma inside there. And as you can see with the 2 LEDs, these are in series. There's a resistor. Now I'm going to just show you what it's going to look like when it's lit up. Now I'm going to use a 9-volt battery. This actually lights up using 12 volts, but 9 volts is good enough. So let me just hook this up. So this is positive, there's negative, and there we go. Now on the camera it looks kind of pinkish, but I can assure you in real life it's red. And if I just turn off the lights, there's a beautiful glow to it. Look at that, it's fantastic. Now again, looking at it in real life compared to how I'm seeing it for the camera, it doesn't look accurate, but I can assure you when you do look at it in real life, it looks pretty close to the studio model. Now, a couple of things I had to be aware of when putting this all together is, if you look at the back, it's all this white here. So what I used was plastic card, to be a bulkhead in between the Buzzard ramscoop and the warp drive, because the blue, I don't want the blue mixing in with the red, and I don't want the red mixing in with the blue. So I had to be really careful to make sure that I sealed off this compartment using plastic card, sprayed it black, sprayed it silver, and just to be, just to really make sure it's not going to bleed, I painted it white. So this strange little component is the navigation light. This is in fact a white LED with a resistor, and this is heat shrink. So if you've worked on circuitry before, you may recognize this. So if you've got exposed wire, you pop this heat shrink over the wire, add a little bit of heat, and then it will shrink half its size, thereby insulating that exposed wire. But this is going to be used for a different purpose, and that's going to be used to channel light from the LED into a small channel into a fibre optic. Now to do so, I just got a piece of heat shrink, which is for a much larger wire, popped it just over the head of the LED, and then just used a little bit of heat to shrink it all down, and that's what is made here, this lovely channel. So all I need to do is pop in a fibre optic like so. Now to give you an example of how this works, if I just hook this up, there you go. So that LED, no light can be seen from this massive LED, and the only light that you can see is coming from the fibre optic. All I need to do is make sure that this bit here is glued up and then painted over with black, and that is how you shine light into a fibre optic and not have any light bleed from here, which you don't want. Okay, since I've started vlogging, one thing I've noticed in the comments section as well as private messages is that I see from model makers wanting to know how to light up their models and feel a little bit intimidated and sometimes berate themselves the fact that they just don't think they could learn. However, it is easy. Granted, I know it's easy when you know how, but look at me, I'm rubbish at maths. I used to be terrible at even soldering and working out how to actually light up an LED. I've burnt out millions of these little things. However, I stuck with it, and what I wanted to do is be able to share that knowledge with you. Yes, I know there's other people from different skill sets watching these videos who may find this part boring, who are from an intermediate or advanced level, but if you don't want to watch for the next couple of minutes, by all means skip to the end, because then I actually go into how I've lit up the interior of the saucer section, see how I built that array from the tutorial that I'm going to give the others now. So skip across. Okay, if you're still here, that means you want to see my tutorials. Okay, I'm not saying I'm perfect, but they do work. So first off, I'm going to show you how to light up a LED using a resistor so you don't burn it out, and take you all the way up to lighting LED light strips and the difference and ranges between them, because sometimes it can be quite intimidating when you look on eBay or wherever you shop and try and find which one to actually buy. Anyway, let's get going. This is a website that every model maker that loves lighting up their models should have saved on their bookmarks bar. Now, if you don't know anything about electronics, do not let resistors and values and not knowing how to make a circuit stop you. Refer to a website like this, which will actually even give you a diagram like here of how to put it together, and as what I'll show you in a minute, it will tell you what components to use to put it together. Now I would say what I'm going to show here is really simple for many people who are very experienced in electronics and LEDs and resistors, and you'll probably be tearing out your hair thinking, oh, you're being lazy, why don't you just use the calculation like everyone else does? But frankly, I'm terrible at maths, and also I'm a very, very casual electronics model maker. I make a model once in a blue moon, and every time I get around to making a model, I forget all the calculations, and even when I do get it, I often get it wrong. That's how bad at maths I am. So if I'm able to do this, anyone else can. So don't let not knowing about electronics or even maths let that stop you from lighting up your beautiful model. Now let's go through the 3 fields. That's all you need to work out what resistor to put with your LED, because if you know by now and you've burnt out many LEDs and you're wondering why, you need to add a resistor
resistor to step down the power going into your LED. Even if you don't use a resistor and your LED comes on and it's fine, you'll find its life might be pretty short as well. And the last thing you want to do is put your model together and your LEDs burn out after a couple of hours. So what you need to do is pop in a resistor, and as you can see, there's no value whatsoever because we need to put in some values in the fields. Don't let all this scare you. Please stick with me when I go through it with you, and I guarantee you will be able to light up your LED safely and it will last almost forever. So source voltage, so you know what voltage is. It comes from a battery pack or it comes from a plug-in adapter. I'm using an Arduino Uno unit and that's 5 volts. A lot of model makers use 12 volts to light up their models, but you've got these lovely little icons there with the question mark. So this will describe to you in a bit more detail about typical values, typical voltage values used in circuits. 12 or 5 is quite common, but we know we are using 5. This is a great thing about this website. It remembers my previous values for other circuits that I lit up in the past. So 5 volts. Diode forward voltage. I have no idea what that is, and for those who know about electronics and whatnot, you're probably tearing out your hair, calling me stupid and an idiot and lazy, but you know what, I only do this once in a blue moon, and frankly, when you've got a website like this where you click onto the little icon, it tells you all the values for a specific LED that you want to use in your circuit. So whatever diode forward voltage is, actually it describes it all up here. It should be 2.0 for a red LED. So if I just close that and pop in 2.0, oh there we go, it's already there because I lit up a red LED before, and that's in there. Now diode forward current, MA. I have no idea what that is, but if I click onto the icon, I can imagine many people watching this now thinking, you lazy sod, can't you just work out for yourself? And I'm like, no, I'm tired. So typical MA, milliamps, that's what that means, whatever a milliamp is. Oh, it actually tells you. It's 20 MA, so if I close that, pop in 20. Oh, there we go, that was already popped in there for me as well. And all I have to do now is press find R, or shall we say find resistor. Click. Ta-da! Here we go. So it's actually told me there's my 5 volt power supply. It could be a battery, it could be a battery pack, or it could be an adapter. There's my LED, and there we go, negative and positive, and there's my resistor, 150 ohms. So all you need to do now, and it gives you the color bands which are on your resistor. Either go onto online and buy a 150 ohm resistor, or just find one in a pack that you probably already have, and that's that. So many of you may even actually say, oh, but I want to use 2 or 3 or 4 different types of LEDs. Yes, that will now affect the resistor value, because obviously there are more LEDs, which means it's going to take up more power, so the resistor value would logically be less. So whoever made this website, and what a lovely basic 1990s website it is, if I just click on to this one, this is their sister page, and this is going to be working out a circuit for multiple LEDs. And the only difference is that it's got a 4th field, and that's for the amount of LEDs that we want to use in our circuit. So again, source voltage, it's 5 volts. Diode forward voltage, if you can't remember, click on the question mark, pop-up box comes up, 2.0, it's because we're using red LEDs. Diode forward current, from what I remember, is 220, yep. And number of LEDs, so let's just say we're going to be using 3 LEDs, and it will let you, you can actually choose how you want to see this. Do you want to see a schematic, wiring diagram? There's a question mark describing exactly what all that means, but you don't have to do that because I want to use a wiring diagram because I want to see what this thing looks like. And oh, it even gives you a little tick box saying help with resistor color codes. I'll tick that because I've never ticked that before. Let's just have a look. Design my array. Here we go. Fantastic. It's giving me a lovely diagram. Very simple. 5 volts, LED, resistor. Actually, it's given me 2 options. So 2 options to make in this array. So you can do it this way. 2 LEDs in series with a resistor. 1 LED there with a resistor of those values. And there we go. That's that. And then this is perhaps the one I would actually use. Very much more straightforward in my head. 350 ohm resistors and a resistor for each LED. So basically what it's done, it said either you can use 2 resistors for 3 LEDs, or you can just basically replicate what we did on the single LED circuit. And that's that. So if you wire your diagram like this, you're guaranteed your LEDs will work, and they're not going to burn out.
Here is that red LED we found the resistor value to. Now with LEDs, if you look at them, as you can see, there we are. So you've got a long leg and a short leg. The long leg is positive, the short leg is negative. And you'll find that with all LEDs. And if you look closer inside the LED, you can also see just the filaments in there that actually make up the negative and positive. So if you don't have the long and short legs because you accidentally cut them different lengths, you can find out the indication of what's positive and what's negative by looking through the LED itself. Now we're going to be attaching the resistor to the LED, and that's one thing I'd say about soldering. If you can do model making, you're gluing stuff together, you're essentially doing the same thing, but you're using weld, or shall we say solder. And so we found that we had to use a 150 ohm resistor. As you can see, this is what I've done to all my resistors. I've just went on eBay, got loads of these little packs which you probably see on TV where they put drugs in them, but I put resistors in these, and I printed out a label for every single type of LED. Yes, it took me all night, and yes, I'm a super geek, but it took me seconds just to locate the resistor I wanted. And I'm going to take that out now. There we go. There's our resistor, and as you can see, it's color coded as per the website's description. So brown, green, brown, and 150 ohms. Now, before we can actually attach this to the LED, we need to prep it. And when I say prep it, we need to actually use something called flux. Now, to help the solder go onto the metal and not bubble off, you need to use a little bit of flux, and it's like this sticky, gooey, greasy stuff. And for years I used to solder without using it and wondering why it was hit and miss if my solder would adhere to the metal, and I realized I wasn't using flux. Now I'm using a toothpick and I'm just popping the flux onto the LED there, and what that will allow me to do is add some solder very easily onto the LED. So let me just pop that there. So there's my solder here. Here's my heated soldering iron, and I'm just going to touch the tip of my soldering iron, because what that will allow me to do is, what will allow the soldering iron to do is conduct that heat straight to the wire. So there you go. And I think the process is called tinning, and so that now there's solder on this leg. If you can see it there, you can barely see it. Now what I want to do with the resistor is do the same. So I'm going to just dip it into the flux, and bearing in mind the soldering iron is really hot, so I'm just going to use the other clamp to hold on to the resistor, and I'm just going to do the same process of, there you go. See the smoke? That smoke is, don't worry, it's not going to kill you. That's just the flux burning off as it's flowing the solder onto the wire. Now all I need to do is just be careful, make sure it's cooled down a bit. Position it in such a way that I can make contact and then use the soldering iron to melt that solder and then weld those two bits of wire together. This is going to be a bit messy because I'm actually just showing very quickly how to do this, but you get the idea. So what I do is this, and that has soldered those two components together. Now this should now be able to be lit. Yes, that is a really long wire there, but not to worry, it is just showing you how to solder and how to work out resistor values for the LED. And to show you how it works, and all I need to do now is show you that it works. So if I just pop it into the clamp here, and here we go. So these are the two wires from that adapter. So positive will go where the resistor is, and the negative will touch upon the negative wire there. There you go. And that's it. Oh yes, I have not forgotten that I am going to show you how to deal with light strips. Before I start on this one, it's easy peasy. So let me show you before I start soldering. So let me take you through the basics of the LED light strip. So this is how it comes delivered all the way from China, and you should not be spending more than a couple of pounds or a couple of bucks on this. So don't go to your local DIY store because they rip you off. As much as I support shops, sometimes they can take the mickey. Now sometimes it can be quite intimidating when you go on eBay or Amazon and you see that there's loads of different values of LED light strips, and those values usually indicate by how many LEDs there are per meter. So the more LEDs there are per meter, the less space there are between them, which means you can pack in more lights and more LEDs in your model depending on the size and what you want it to do. There is no right and wrong, you just have to do it with trial and error and your own experience. And one thing that's beautiful about this, yes, it comes per meter. You can cut this at any point for every 3 LEDs. So if you look closely here, you can see these little copper points, and if you look closer, there's a little scissor icon as well, meaning that it's telling you you can cut here and solder 2 wires there and it will work. So this is great for the novice beginner electronics model maker who wants to light up their model and they're a little bit intimidated with working out resistors, because resistors are already embedded into the LED light strip, and that's why there's 1 per 3. Now there are different values for light strips in regards to how many LEDs there are on a meter, which I explained to you, but also you've got waterproof versions of LED light strips. You can still use this, however, as you can see, there's a rubber membrane on top of that, and it's an absolute pig when you want to be able to solder wire and new connections onto it, as you can see there, because you literally have to get a scalpel, really sharp scalpel, and carve off the protective membrane, and it's not worth your time and trouble. So I don't advise you, when you do buy an LED light strip, just avoid the waterproof ones unless you've got a model that's going to go underwater or outdoors. Then you've got light strips like, let me show you this one, like this. So the LEDs are huge, and if you are lighting an inside of a starship, be careful not to make it too bright, because your windows are going to be so bright you can imagine the occupants being blinded. So you need to add a sense of realism to your model, so not too bright, so you don't need to go OTT with the size of the LEDs. And also I've heard many people talk about overheating. LEDs, as you full well know, if you touch them there's hardly any heat whatsoever. I've packed in loads of these LEDs in very small compartments, and I can assure you it's never been an issue. If you had an issue, it'll be interesting to know why. Leave some comments down below, but I can assure you my own experience, and a few other model makers will actually back me up on this one, you don't have to worry about heat with this. How to power and wire up a LED light strip. But as I said before, it often comes with connections already, so all you need to do is just take it out of the packet, and then there you go, positive to negative, and it doesn't matter if you get it the wrong way round, nothing's going to blow up. There you go, job done. However, it's going to be very unusual for anyone to use all this in one go without breaking it up in segments, and so that's what I'm going to show you how to do. Now if you look closer, you can just see the little icons of a pair of scissors, indicating you can cut any point along here throughout the entire length of this LED light strip, and all you need to do is wire these points together with a piece of wire, so it means that you can space them out, and that's what we're going to do. So here's a pair of scissors, so let's just pretend this LED bit here is going to go on one side of my model, and the rest over here is going to go on the other side of the model. Let's just say they're 2 different warp drives because it's blue. So let me just make sure you cut carefully along that seam, like so. There we go. Now the beauty of this, it still works. There we go, you see. Let me just get that right. There we go. Works beautifully. However, this is now disconnected, and I want this to light up on the other side of the model. So now we've got to connect this copper point to that copper point, and this copper point to that copper point. So if you can see just clearly here, there's a positive and there's a negative. So long the wires are connected to the right terminals, so positive to positive, negative to negative, all you're doing is continuing that power source all the way through the LED light strip, and I'm going to show you how to do that. Now, first thing you need to do is get yourself one of these. Got myself a lovely little arm here, just to hold on to the LED light strip. I'm getting busy. Let me just move the light out of the way because it is quite blinding. And I'm going to get some flux, like I've done before with single LED light strips. This just makes it easy for me to be able to actually solder the wires together once I get to open it. There we go. Bit mucky, this stuff. I'm going to pop some here, pop some there, like so. Now all I need to do now is get my soldering iron and then just put a blob of solder there and a blob of solder there. There you go. That nice shiny little coat means that's ready to actually have wire connected onto it. Now I'm going to do exactly the same thing to this part of the LED light strip as well. So exactly the same job. Oh, sorry about that. Exactly the same job. If you can just see, it's probably a little bit out of focus, but you get the general idea. So same job, little bit of flux either side. Feels like grease. It's not exactly the nicest thing to touch, but I used to solder without this stuff and it was a bloody nightmare until I found some. And there we go, just a little bit there, because I had some solder already on the tip of this. It's already transferring onto the copper points like so. Take this off, and this is a great thing about electronics. It's so quick compared to, well, when you're making a model you're so used to waiting for glue to dry, and you don't actually have to do that with this because solder dries, it cools down very quickly. So I've got these two clamps, hold on to one end here, and what I'm going to do is attach the wire. So as you saw, if you can zoom in there, that's positive and that's negative. So my positive is purple, and again, for those people who are pretty anal, like you can use whatever colour you want. It doesn't have to be a red or black or God knows what. It's so long it's identifiable, because you don't want the wire, like positive and negative, all to be the same colour, do you? Otherwise you're just going to get absolutely mixed up. Now that's making contact now, and I'm going to use a solder to melt those two bits of solder together, and that should fuse like so. Done. So that's one. I can probably do it without that clamp as well, because even though it does get hot, it's not exactly gonna scorch my hand off that quickly. So if I just do the same thing here, there we go, instant. And now what I'm going to do, I'm going to attach this to that. So positive, positive. That's really important. Let me just focus that. See that? Positive to positive. So this wire is going to positive, and you're probably sick of me repeating myself, but you know, this video is for people from all different walks of life, all different levels. Some people may need to have it explained slower than this, but just bear with me. So same thing, solder, there we go, instant, and then solder again. I need to just bring that closer, solder again, there we go, and that's it. I know, right? So actually you want proof that it does work, so let me just zoom out for a bit. Actually I'll just keep those in the clamps so you can see, and then I'll get the battery and I'll just plug it in. There you go. Oh, let me just make sure that's plugged in. There you go. So there we are, two bits of light strip disconnected and reconnected by this wire, which means, as you can see, you can space them out across your model, and that's essentially all you have to do to light up your entire model. You don't have to work out resistor values, you don't have to do anything special. If you do this, you can light up any model with no hassle whatsoever, and all for a 9-volt battery. I don't recommend a 9-volt battery because batteries run out very quickly, but I do recommend getting yourself a variable adapter. It's basically a plug which can regulate between 5 volts to 12 volts depending where you're getting that power supply from. So I hope that helps. So what I've done there, I was able to do this. Yes, this is the inside of the Enterprise D saucer section, and as you can see, I've done that same technique of cutting segments of the LED strip into little parts. So every 3 LEDs wire, 3 LEDs wire, and that is all connected with this wire. And there you go. If you look closer, as you can probably see there, what I've done, I've actually got 2 pieces of plastic and made them into a L shape, and so I have some LEDs on the left and LEDs on the right. So LED light is going in all different directions, bouncing off the silver interior of the model, and that's all you have to do to light up your model. Is that not easy? Please, this is simple, so give it a go. You may run into trouble when you actually get your connections mixed up, because I did. I know I'm an idiot, but all you need to do is unsolder and resolder. Practice, 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 and I guarantee you'll be lighting your model up very, very soon.
Library computer data.